Just to briefly introduce myself, been at NetApp for 10 years. I have about close to 25 years of SAN background. I worked at NCR doing SAN for NCR, worked at HP doing SAN for HP, used to build storage that was Teradata optimized systems back when NCR owned Teradata. And from there on, I've been part of first generation fiber channel. So I've been on fiber channel since 97. I did the first generation fiber channel for HP, wrote the initiator stacks for HPUX, pretty much the entire stack. The first gen fiber channel private loop, first gen public loop, first gen switched FC, was part of the iSCSI RFC, very active on the RFC side, was part of the SAS standard, and then worked closely with Hitachi when the first HDS product was built with HP in stealth back in 97 in a warehouse in Roseville up here. And since then, I've been part of pretty much all of the SAN innovation at NetApp. So I was the architect for our SAN product at NetApp. So the clustered on tap SAN, I led the architecture for that. And most of our SAN feature set up until about 3 years ago or so, I've led for the team here. I've been part of our VMware agenda. All of our VMware features I've led and architected and driven along with VMware as well as with Hyper-V. So every virtualization feature that NetApp has put out in the last 10 years, I've been part of leading that and been part of that. I took a shift in the workload space because we started to see the industry move in very different directions, and we are seeing a role for the enterprise vendors to influence the thinking in that space. And that is actually a topic around the data pipeline. I'm going to talk about what is a data pipeline and introduce that a little bit, but before I do that, I just want to set a little perspective because of our view of the industry from an overall ecosystem perspective. There are two things that we see. One is the enterprise install base has really rallied around anchor tenants for the install base. So VMware has been the anchor tenant for the longest time. And there are a few important shifts that we have seen away from that anchor tenant, which is as the application space moved from the second platform to the third platform, which is shifting away from RDBMS and traditional enterprise apps into architectures that are NoSQL based, big data based, and starting to leverage the new ecosystem of streaming ingest. VMware wasn't the key player for the on-prem enterprise. So the market started to shift from VMware towards Linux and KVM or Linux bare metal or Linux containers. And that started to affect the on-prem market. The second thing, of course, is the cloud vendors. They started to obviously shift the market away. But on the other hand, if you look at the pricing of data in the cloud, and particularly where you have data that has to move in and out of the cloud, the unpredictability of pricing has always been a concern for customers. And we at NetApp have seen that customers that went in at scale have often come back to us because of unpredictability of pricing. So what we've found is there is an opportunity in the industry. There's truly an opportunity in the industry for vendors that can build a data pipeline that gives customers data independent of where you want to deploy it. If you want to deploy it on premises, you want to deploy it in the cloud, or we also see the emergence of the edge. As you look at the edge, we see that emerging as a space where technology is starting to shift to. Now, if you take a step back and go back to the third platform ecosystem, the origins of that third platform ecosystem is largely around web scale vendors. So you look at the whole Hadoop stack, that came from Yahoo. You look at everything around Cassandra, a lot of that has come from web scale as well. Same thing with Bigtable and so on. What works for the web scale cloud vendors doesn't work for the enterprise. And where the enterprise has struggled is in exactly that dilemma. Where the enterprise has struggled is they have tried to build out these commodity-based architectures. And these commodity architectures are 3-copy and 5-copy architectures. And you can do a 3-copy to 5-copy architecture as a POC in a line of business at small scale. But when you start seeing data sets growing to a petabyte plus, 10 petabyte plus, 100 petabyte plus, and now you're doing 5 copies of the data, and you're doing it for each application component, it is unsustainable. So we truly see an opportunity for vendors that offer storage to play a role in this space. And today, if you look at the whole ecosystem around third platform, there's a dichotomy. If you talk to application developers, none of them want to touch Oracle, SQL, SAP. Particularly, they don't want to work with premium paid products for the application development space. If you talk to the infrastructure teams, they can't sustain infrastructure at 100 petabytes across 5 copies, across 4 different components that are being built. So a 100 petabyte data set streaming in from IoT endpoints goes through a pipeline that is replicated 3 to 5 times. Lands up in a data lake, gets replicated 3 to 5 times. Lands up in another copy for the data warehouse, maybe another copy for the AI space. So the space is dealing with the stress points of the application developers that want the agility and the infrastructure folks that can't sustain what the app dev guys are doing, because the app dev guys are mimicking what the cloud space has done. So there's an opportunity for a data pipeline that balances the needs across these players. So to hit home a few of the key points, when you start to look at, and especially this room really appreciates it because you are deeply aware with systems architectures that have worked for 20 years. And what has worked for 20 years has been pragmatic scale-up, pragmatic performance scaling, and focus on efficiency in a balanced way. But you look at what commodity architecture with web scale does, it throws hardware at the problem, it throws copies at the problem, and it takes the point of failure to a unit, which is a rack or maybe even a data center, and says, if I can replicate data across racks for availability, if I can replicate data across data centers for data center availability, that model works. It certainly works. There is no doubt that model works for the cloud. But customers on premises in the enterprise can't afford the unpredictability of that model. What I mean by that is, when you start seeing drive failures and node failures, you go into performance rebuilds. So applications that are built on top of those commodities for the enterprise start dealing with the unpredictability of performance failure. So you take a modern database like Cassandra. Cassandra actually requires weekly database rebuilds in order to manage the rebuild of the database and not go into a state where you have to go offline for repair. So starting to think about the dichotomy between the application developers and where they want to go, which is all open source and not working with the traditional base, but keeping the operations focused on systems guys, is a space where we're seeing an opportunity. The second point I'll make, just because of our opportunity here as NetApp, as a systems vendor playing in the cloud space, is we think that the industry was distracted for a little while with the Hadoop vendors. And what I mean by that is, the Hadoop vendors said everything can be commodity and software, and you don't have to worry about those old systems guys anymore. And the industry took a left turn towards the Clouderas and Hortonworks and MapRs of the world and said, we're going to go innovate around the Apache software ecosystem, which is great. We love that. We absolutely love that. But we believe that the data is going to outlast those component vendors. The data is going to outlast those component vendors. What we mean by that is when you start to look at MapReduce, just as an example, MapReduce has been disrupted by Spark. Spark has been disrupted by Kafka and Kinesis taking over some of the streaming. And Spark is now being disrupted by TensorFlow doing real-time AI. So if you take the customer's data as their main asset, which they've got obviously deal with for 30 years or whatever period of time for compliance and everything else, that data has to be surviving the ongoing series of components that are going to come along. So we think that a data pipeline that maintains the 25 or 30 years of systems architecture in terms of it's got to perform, it's got to scale, it's got to do all the things that we've had to build as systems architects, but can decouple from some of the open source oriented application development components, is actually a model that has legs. If somebody can deliver that, we see the cloud vendors actually doing that. So we think that the cloud vendors get that their presence on premises is key for IoT and for the edge. And we're going to see the cloud vendors clearly make an impact. Microsoft, in fact, with Azure Stack, has a very strong play there. And we think that the on-premises base is simply too distracted, with the exception of a few vendors that have stability. Of course, we see Oracle doing that too with Oracle Cloud and the Oracle appliance. They have a viewpoint. But again, customers don't want to pay the premium price point. So it's a balancing act between the overall IT budget shrinking, customers not wanting to pay for certain things, but needing the flexibility between predictable pricing models, predictable architectures, and the ability to scale where they need to. So with that, I'm going to go into the components around where we see the data pipeline. There's one point I want to make here, which is a lot of customers are going into the cloud, which is great. But when you think about IoT, and IoT is in every industry vertical. There is absolutely no industry vertical where there is no IoT today. And if you have a customer that say, I'm not having an IoT strategy, then that customer is going to be obsolete. So they've got to think about IoT. Now, when you think about IoT, there are two profound shifts that are happening. The first is customers are creating data at the edge. Petabytes of data are going to originate from the edge. And that data has to land up in a data lake that has a 7-year lifespan, so the cloud is guaranteed. So what they end up doing is saying, I've got to just put it all in the cloud. I'm going to go from my IoT endpoint into the cloud, all in. What they're going to miss, and we are seeing some customers see this, is you don't just put the data in the cloud. You start to build business intelligence on the data. You start to build artificial intelligence and deep learning and machine learning on the data. And when you start to do that, it becomes a bi-directional data flow. So you're not just creating the data and putting data in the cloud, but you're starting to push data back into the edge because you've got these machine learning models that need to go back and run on the edge device. And what's going to really be a sticker shock to customers is the increasing egress of data out of the cloud. When you start seeing the inference models are not big in footprint. And we're not saying you're going to be pushing inference every hour or every 4 hours. But when you count the millions of endpoints that you have and the fan out of data that needs to happen, if you think about your iPhone as an IoT endpoint, and if you imagine that the cloud was where you were doing a lot of your innovation, if you had to push an AI inference model for an application that's on the phone to millions of phones out there, that's going to start hitting your cloud egress model. So we think that there is truly an industry opportunity. We are at the crossroads of data needing a solution that can span edge, core, and cloud. And so we believe that we are seeing this earlier than many of the players in the industry for two reasons. The first is the cloud vendors have a stake in getting data into the cloud. So they're going to look through some of this and say, hey, just move all your application development into the cloud. The edge is really the cloud. So if the edge and the cloud are all in the cloud, you've got no issue with the physical. The problem with that is physical endpoints are going to exist as a reality of the nature of the consumer experience. You have consumer IoT, you have industrial IoT, you have a number of automotive experiences, all of which have physical endpoints. So you can't deny the origination of data at a physical endpoint. The second part is all of the on-prem vendors, with the exception of NetApp, have either ignored the cloud for too long or are small enough that they don't have a cloud play at all. Many of the traditional storage vendors or SAN vendors simply don't have a cloud play. Or they don't have the stability because they tried to be a cloud vendor and now they're going back and forth. So NetApp is at a unique point right now where we are not aligned with any of the cloud vendors, and therefore we are the best friend of all of the cloud vendors. We are not aligned with any of the application stacks, and so we work and partner with all of the application stacks. So we are actually able to focus on what we do best, which is data. And if you accept the premise that data is going to outlive these app components, we have a role that we think is well suitable for addressing the data pipeline. What about this architecture does not work when you go to edge to core to cloud? So we are seeing that customers are taking the third platform architecture, which was built for web scale, taking it on premises, starting to scale it into the edge, and starting to scale it into the cloud. So let's take a second to talk about what about this architecture doesn't work. There are two things in this architecture that doesn't work for the enterprise, unlike what it does for the cloud. The first is when you run this in the cloud, you run it as a service. So you don't have a wide install base of customers that are deploying the platform or the stack, and you can run on a single version and it's operated by a closed set of people. If you move that model into the enterprise and the install base of the enterprise, you have to do software upgrades. Software upgrades are a nature of life. Customers have hardware in thousands of controllers, and they're going to have different stages of upgrades across their install base. When you start looking at this open source ecosystem and having to manage thousands of controllers deployed for 100 node Hadoop, 100 node Cassandra, 100 node Kafka, and so on, you've got to manage different versions of that. And if you bring in the application upgrade across this ecosystem, it's unsustainable. It's unsustainable. So they start dealing with, I've got to do upgrades, but wait a minute, all my data is sitting in the server. I've got server-based DAS, and my server-based DAS can't actually decouple my data from my compute. So you're finding two things that are going on. One is upgrades are impacting this technology. Migrations aren't even thought through right now, because these things started as line of business. Somebody that knew Hadoop built out the architecture. But wait a minute, all of a sudden that data set got to 1 petabyte. And you got 5 copies of that, and you got more coming in, and there's no answer. How are you going to do a technology refresh of 5 petabytes on a 100-node server cluster that's sitting with data in integrated drive shafts? How are you going to take that architecture and upgrade it? How are you going to upgrade it when you got to take the data out of MapReduce, move it into Spark, move it into TensorFlow, when all of the data assumes HDFS, and HDFS simply doesn't work for many use cases? When you start looking at real-time performance, you start looking at TensorFlow. HDFS, which was built for hard drives for post-processed analytics, isn't the answer in the world of NVMe and NVDIMM and everything else we've talked about. So we start getting into what do we really need? What is the vision for answering some of these issues? You need a next-generation data pipeline. A next-generation data pipeline has got to be a unified architecture that is a data lake but can federate different data sources. What we're seeing, here's the other element that we see. Hadoop has had its push on the premium second platform data warehouses. So when you look at Oracle, SAP, Teradata, all of them are feeling the effects of Hadoop. And they're having to put analytics into their traditional data warehousing product. They're having to put AI into their traditional data warehousing product. So customers are going to build business intelligence that spans the data lake as well as Oracle, SAP, Teradata, and pick your favorite traditional warehousing appliance. Snowflake and vendors like that are trying to fill in that space as well. So in order to address this space, you really have to deal with a balance across these three stakeholders. The reason we are here today, if you take a moment to say, how did we land up here? We landed up here because these three stakeholders have diverged and have diverged from two dimensions. They have diverged from a power dimension. The data scientist and the app dev community has gained power in the customer's organizations. And as they've gained power, they have become the decision makers. At the same time, the infrastructure folks, the folks that we have traditionally worked with for 25, 30 years, haven't been able to keep up with the shifting components and the landscape of the technology. So when you're throwing in a new software component into that open source space, every year or every 6 months, the IT admins can't keep up with the technology. And so a balance means you've got to build agility for the data science guys and the app dev. You've got to abstract the application space from the infrastructure folks and offer it as a service. You've got to start thinking of data as a service. A data pipeline is basically data that can span edge to core to cloud, that can offer data as a service, that can be operationalized by the IT operational folks without having to know all of the intricacies of the application ecosystem. Is that making sense? I want to pause here and look for your thoughts and reactions. And we really believe that this is going to be something we've got to think through and influence. There's truly an opportunity here to have an impact on customer thinking around this because they're struggling. They're struggling through all of the choices we have talked about. And by taking the 25, 30 years of systems background that we have, the traditional application background that we have, but applying all of those principles to where this industry is going, there's truly an opportunity to shape people's thinking.
You know, you guys don't seem to have much of a play at the edge, I would say. Right? I mean, you've got no specific, hardware functionality there. You're not playing in auto cars or bridges or consumer electronics and any of that stuff. So you have to stand aside from that. Obviously the core you're in a big way, and the cloud is another area which you don't have a big base in to some extent. So how the data as a service is going to handle those three and be a NetApp solution is yet to be determined.
And that's a great point. I'll add a couple of things. We have partnered with Vector Data. I don't know if folks have had a chance to look at Vector Data, but I'd encourage you to look up vector data and ONTAP. So we've put ONTAP Select, which is our software-based ONTAP, on a very small footprint, ruggedized vector data platform. In fact, I wish we had brought a box in here and just put it out here. I've been telling our field folks, every time you walk into a customer call, carry a vector data box with you. It's this small, literally. It's smaller than this box. It's literally like a half of this box. We're running ONTAP on half of this box. You could throw it in the trunk of a car. And we think that vector data is well suited to position software-defined ONTAP Select into industrial IoT use cases, retail use cases, and autonomous transportation use cases. We are certainly not there yet with consumer IoT, but we think consumer IoT has to evolve beyond just the smart home itself. There's got to be those junction boxes, the cell phone towers, the sub-mile and sub-market and last mile infrastructure that has to build up to aggregate data coming off of the smart homes. And so we don't see ourselves necessarily in the smart home, but we see ourselves as infrastructure vendors that can supply data infrastructure for the last mile. So we're partnering with vector data. We're exploring other partnerships that I can't talk about, but vector data is a very, very interesting product for us. It's a ruggedized platform that gets out into all kinds of footprints out there, whether it be out in the field in hostile remote environments, or whether it be in industrial environments.
Santosh, if I could just real quick, his point, right, is even going beyond vector data, right? It's the software layer for us, and the fact that we're not putting a bunch of physical devices out there. You're right, we're not out there selling Wi-Fi cameras or something like that. But on the other hand, we're a neutral third party, right? It's like a lot of the people who supply automotive software are not the automotive manufacturers, right? There's a couple big vendors who, because they're basically Switzerland, right, they can supply software to all of these different vendors without having to put the hardware out of place. So that's a huge part of our strategy. If you think about it in a car, no one is going to put a storage appliance in the back of a car, right? It's going to be embedded software running inside the car, on embedded, eventually persistent memory sending it back, and that's where I think we have to play. So.
And I would say that the edge is actively evolving. So we talk actively to customers that are building out edge solutions, and they're building with what they have today. So they're taking hard drives into automobiles, capturing data in a car, destaging data at the end of the day from a docking station or a docking point where you have enough network bandwidth. But as you start to look at the data set increase there, they've got to do something more than just local drives in a car. They've got to do more than having just open server infrastructure in a retail store managing that data. Because you're going to push two things. You look at what NVIDIA is doing with TensorRT, Tensor Real-Time. They're pushing analytics and AI to the edge. So as you start to do more and more intelligence at the edge, you're going to need infrastructure that has performance at the edge. You know, everything we talk about from PlexiStore perspective, where we can bring NVMe Fabric or PlexiStore into hundreds of microseconds down to tens of microseconds of performance, that is a killer app for TensorRT at the edge. To the point of partnerships, we fully agree that partnerships are key. It is not going to be a NetApp solution. We do not want to be a NetApp solution, but we want to be behind, on the cloud, we are behind Azure Marketplace for file today. At the edge, we are in the form of a vector data. And we're going to seek out those few partners. And I'm personally involved in our partner strategy. I can tell you, we're working actively across partnerships with NVIDIA. We're working with partners that bring us the platforms. We're working with partners that do consulting for AI and deep learning and machine learning, because those are the guys that are really going to sell those new workloads. And so we truly don't want to be the one and only brand out there. We can't be that. We're not going to be that. But if we can show that we have no alignment of our interests that conflict with our customers, then we have a very solid role there, because we're seeing examples where this just came out. I don't know if people saw this, but Walmart is telling its suppliers, get out of Amazon Cloud. If you're a heavyweight industry vendor and you're telling your suppliers, I don't want you doing business with my competitor, that changes the game. That brings multi-cloud use cases to life, where that vendor may need to work with Amazon in certain cases, but may need to work with Azure or something else for other use cases. So our role is not to give a NetApp solution that's end-to-end, but to give the foundation that we can deliver to partners that are different partners. We will work with the cloud partners to supply technology. We'll work with the edge partners to supply technology. And so that's sort of how we are looking to shape our customers' solutions. I can tell you, I was at Strata this week. I spoke at Strata. I should have said this. They've got me speaking and actually writing on this topic just because we can't get data and thoughts out fast enough. Our traditional paths to market has been so slow that we can't get data out fast enough. And so they got me starting to write. So off my LinkedIn page with the profile photo of the field day, I've started to put out a few of NetApp's thoughts as I won't call it a blog, but starting to write, get the word out, and starting to talk a lot more. So we spoke at Strata. We had over 100 people in our session at Strata yesterday, and starting to see that truly resonate, even with the cloud vendors. So we had Microsoft come up and say, what can we do with Azure Stack? How can we get this kind of a data pipeline working with Azure Stack in a way that Azure Stack is able to go after the traditional enterprise install base? So those are the kinds of things that we see this driving. From a technology perspective, what's changing? There are a few things that are changing that are very critical. The first is at the edge, we are seeing TensorRT bringing performance as a killer use case for the edge. Those that can do high performance for AI at the edge are going to outcompete those vendors pushing data into the cloud or into the core for AI. So PlexiStore as a solution, we're innovating on the technology side with all the things around NVMe and NVDIM. But if you start applying it in form factors like a vector data, if you can bundle a PlexiStore with vector data, running TensorRT at the edge, all of a sudden we are giving customers a competitive differentiation that they can't refuse. If you take that box into a Target or a Safeway or an American Express or Visa, you're giving them technology that they need today. They absolutely need to leverage AI in a way that works for them in a physical footprint at a retail store. You've got Walmart doing robot surveillance of the aisles to look at how do I influence my data set there. So putting performance coupled with ONTAP Select, a data tier that is PlexiStore with ONTAP Select at the edge, that leverages SnapMirror for smart data movement, starts to become our foundation for the edge.
You really think you need to have millions of IOPS at the edge with sub millisecond latency? I mean,
we don't see millions of IOPS, but we see sub millisecond latency. So TensorRT is about sub millisecond latency. It's not about millions of IOPS. So we will look for the ultra low latency coupled with data.
But you're talking about putting storage class memory into the edge devices. I mean, give me a break. There's got to be the cost has got to go bananas there. Banana is not the word I would use, but
So it's a fair point. We see the edge as a hierarchical edge. So we are not looking at edge as, hey, it's the last. I'm not going to put ONTAP Select on my phone, obviously. I'm not going to put it actually in a sensor device in the car. But there is a need to aggregate. You've got 20 terabytes of data coming off of the transportation vendors that are having to map the streets. You got 7 terabytes of data coming out of every car. We know this because these are our customers.
It's per day, right?
It's per day. Per day, per car, you got data coming out in 2 types. You're going to have consumers driving autonomous cars that produce up to 10 terabytes of data a day per car. You've got the manufacturers mapping streets out that are doing anywhere from 20 to 100 terabytes per day per car. These are the cars you see driving around from Google and Huawei and all of those, Baidu and all of those. So that data set is going to need storage. Now, it's not going to be us at the sensor level, but you can bet we're going to look at vector data with the autonomous guys. And we are already in retail stores across the US with vector data today. We have a retail brand that puts a vector data and has actually put the FAST 2500s in every single store. So this is happening, and it's happening because people need to solve these real business issues.
And Ray, this is a bit of an exaggerated example, right? But if you've got an autonomous car and you take a turn and midway through the turn it discovers that only 2 of its tires are touching the road, the response time in being able to do that, a truly autonomous car, that matters, right? And obviously I'm doing the example, but so it's not about millions and millions of IOPS, but if you've got literally probably a few milliseconds to make a potential decision on saving a human life or not, right? Reaction time actually matters for those autonomous systems.
Yeah, and I would agree that the millions of IOPS is in the core, where you've got training clusters and data lakes. Where you see the millions of IOPS is in the core, where you see latency use cases at the edge for ultra low latency.
I mean, the challenge is, I'm not sure what the numbers are, but let's say there's 15 million cars sold a year. you're going to put a storage class memory device in 15 million smart cars in 10 years, 15 years? I mean,
There's NAND flash and that many million cell phones running around right now.
yeah, but that's TLC or QLC flash. It's the cheapest thing they could possibly find that supports 128 gigs or whatever. It's
Agreed. But it was the
not-
most
it's not-
expensive thing you could
10
find
years ago.
7 years
It
ago.
wasn't.
So
10 years ago, it was expensive as hell, right?
So-
But they weren't putting 128 gig, and they were putting 12 or 8.
But here's the point. If you can expand your thinking beyond the car to a sub-mile.
Are you saying I can't expand my thinking?
No. Well, what I'm saying is if you can expand the edge definition to a hierarchical edge, you got to have infrastructure in the last mile that can deal with destaging of data off of cars. Is that going to be vendor service stations? Is that going to be gas stations that can rent things out to automobile vendors? It's certainly cell phone towers. If you shift from automobile to telco has infrastructure today in cell phone towers. So we certainly see IoT gear expanding in cell phone tower type footprints. Now, what is the answer for automobile? We don't know. Is it service stations and gas stations? It could be. If I were a gas station owner and I can rent out for cash flow to all of the automobile dealers out there, floor space to put infrastructure, I'd happily do it. It's a great business opportunity for every gas station. The point is, who's going to educate the industry?
Two questions. So two things. First of all, to Ray's point, the reason I disagree with you, I think, because data is like a hermit crab, right? It's gonna as soon as it's gonna grow out of its shell, go find a new one. It's gonna keep growing, get bigger, and the needs will get bigger, and the needs for low latency will get bigger. I think that's been proven over time. It's not a Moore's law thing, but it's something like it, right? But my question for you, more NetApp specific on the edge, you said that you're gonna have Plexus Store and NetApp Select. Wouldn't it be a better architectural direction to just put some of the data mobility stuff directly into Plexus Store and put the LRSC engine in there so we don't have to have two things, right? And so that I would think that would simplify everything, and so that the ONTAP stuff sits in the core, maybe in the cloud, but at the edge to have an ONTAP instance out there along with your high performance, that just seems like that's a lot to manage. Number one, it's going to be very complex. And when you really just I need to ingest fast for my TensorRT and then get it the hell out of there to my bigger lakes. And doesn't that make some more sense?
Yes, it absolutely makes sense. In fact, I talk about TensorFlow and ONTAP Select because that's the goodies we have today.
Yeah, right.
But yeah, you're clearly leading beyond where we are today, and I can tell you that those are active thoughts that we have. Now, it's going to take a while to get there, obviously, but we are working with what we have and working towards where we want to be. But fully agree with you that the lighter your footprint, and at the same time, the smarter your data infrastructure, there's an opportunity. But I think the bigger opportunity isn't about what this particular component can do, but the bigger opportunity is thinking about how a set of thinkers, like the folks in this room, can really influence how customers are thinking about it. We find customers are struggling to manage. They're taking data in. Many of these customers are not software customers. We are talking traditional brick and mortar customers that have never been a software company, that are having to just throw whatever they've got at the problem. So there is an opportunity to shape the thinking of customers, to take on a systems view. And systems thinkers that have sort of stayed on with the second platform view have a real opportunity to leapfrog into the new world of a data pipeline. So if you could think about the impact that this room collectively could have on shaping the view of a data pipeline across brick and mortar customers that never really understand technology, and we could build this thing out, I still think we are the guardians of data. I mean, I could brocade the guardians of Fibre Channel. There's got to be a guardian for data. It's not the cloud vendor. The cloud vendor was never the guardian of data. It was never about managing customers' data. It was about building infrastructure and getting infrastructure consumed and applications built on that web scale infrastructure. So I think that I'm personally excited because I think we are, being a SAN guy at NetApp, I've always been catching up. I've been building to address the SyncDR gaps or the HA gaps or the takeover gaps, or I've had 10 years of catch up. And I think industry has given us a point where so much of instability has led to a lack of enough of a vendor ecosystem to play this kind of role to shape customers' thinking. And I can tell you, we are actively finding ourselves influencing customers in ways we never thought. I'm having these conversations with web scale vendors. Folks like Twitter, Lyft, Uber, Pinterest want to hear about it. They obviously have a point of view. They're building their own, but they're at least listening to what we're saying. And we think that this has a certain merit, and we're going to continue to pursue this. When you look at what are the 5 factors here that matter, a file system and a data store that decouples from the application. HDFS is so tied to the Apache stack that now you take data in HDFS into TensorFlow or into an NVIDIA AI stack or even into an HPC. So you're looking at, I haven't even talked about GPUs. I mean, I could go a full hour talking about GPUs. If I were to talk about GPU as the single biggest system architecture change, the way that GPUs is changing application development, the way GPUs are changing performance workflows, HDFS was never meant to work in a GPU-like performance use case. If you look at all of the things you can do with GPUs. Now, are customers dealing with this today? You bet they are. They can't afford the other copy. Hey, I got 10 petabytes on HDFS. I'm going to copy it into a file system for TensorFlow on NVIDIA. Nobody wants to do that. So they're trying to, I'm going to just read off HDFS, see what I get. The reality is data sets aren't at the scale where performance is an issue, except for the customers that have really started to step on the gas pedal in this space. What I mean by that is the autonomous vendors putting out those driverless cars and actually pushing the industry from a autonomous technology are building data sets. We'll look at US federal and defense use cases where they've got surveillance videos. They've got the appetite for 300 gigabytes of bandwidth. I was talking to a customer yesterday that I cannot name. 300 gigabytes they were willing to consume. I was telling them about what our A700 can do and where we're going when you can scale 12 HA pairs of an A700 into a single namespace of a file system, giving you over 200 gigabytes of bandwidth. They said, I'll consume 300 if you have it. Have your account rep call me. So we see the opportunity to build a file system that decouples from the application stack, that delivers the balance of performance, that gives you the ability to have the data pipeline federating traditional second platform data warehouse and database applications with the third platform web scale applications, but doing it as a service. The reason as a service matters is because the infrastructure folks can never build their knowledge base of the changing ecosystem. So what we want to do, our vision is give you a UI where you can say, I want to provide a Hadoop service that's 1 petabyte, and I'm going to distribute it across the following racks, and I'm going to give you the following components with Spark turned on, Kafka turned on, and pick your favorite component. And that UI should actually go ahead and provision data. We're doing that today. We've got integrations with Hortonworks and Bari UI that actually does that level of simple provisioning. We've got integrations for MongoDB that will provision you across 5 data centers. If you've got a NoSQL database like MongoDB or Cassandra, it's not about storage in a rack. It's not about storage in a data center. It's 5 data center sharded NoSQL databases, and we've automated across 5 data centers. So we're building innovation in multiple dimensions. We're building technology innovation with NVMe and all of the story there. We're building platform innovation with ruggedized platforms like vector data and ONTAP Select going in new places. We're building the cloud integrations. But we're building solution integrations at the data pipeline where we can now go after data as a continuum and do it as a service and do it abstracting out all of the ecosystem players that are out there.
Well, it seems to me that you guys are really expanding the data fabric story, isn't it?
Absolutely. We think that the data fabric was ahead of its time as a vision. We think that IoT is the killer app that makes data fabric real. If you think about data fabric, when our CEO, George Kurian, started talking about it several years ago, you could talk about data fabric and it's a nice thing to say, but there wasn't a killer app use case for it. The cloud guys did their thing, the on-prem guys did their thing, and when customers had to do a hybrid, they'd say, my legacy projects are here, my new projects are in the cloud, I'm done with it, I don't need to federate. What has changed is when you look at IoT, the same application and the same workload has to span across deployments. You can't have 100 petabytes sitting on-prem. At least many customers want to push archive into the cloud. They want the cloud for cheapest storage cost. And you can't have the cloud sitting at the edge by the car or by the consumer IoT. So you've got to bridge the two. So we think IoT is the killer app for data fabric, and we see the data pipeline is extending data fabric to the edge. What the data pipeline does, and data pipeline is an industry term, right? If you talk to the big data guys or the AI guys, data pipeline is an industry term. Everybody uses it in their own way. our viewpoint on data pipeline is different from the rest of the industry. How is it different? We take the point of view that data is truly decoupled from the application components that are going to be shorter lived than the data itself. And here's the other thing. It's nice to have a big data for hypotheses that you want to validate and say this is a predictive analytics or a prescriptive analytics. It's another thing when you put human life in the hands of decisions made on top of that data. When you put an autonomous car out on the road and it has an accident causing a casualty, litigation comes into play. Litigation has consequences. It brings back the importance of availability, and it brings back the importance of data compliance and data protection. You need to protect and manage that data for 10 years or more to meet with all of the litigation compliance rules when somebody files a lawsuit because that autonomous car vendor went into mass crashes. I hate to talk about these kinds of things, but if you had a vendor that had faulty AI models controlling the car that went into certain scenarios where you had mass crashes, you need to go back and pull out data to look at litigation around AI models that were built 5 or 10 years ago. So doing it on hard drives and dumping it in an HDFS lake with no strategy around data protection simply doesn't work. And this resonates with customers. When you talk about SnapVault and the ability to do intelligent data protection, smart data protection, and do it for a long term, when you talk about compliance and litigation, all of these are changing big data. What worked for big data as a science project in the line of business is not the same when you start using big data for human decisions that impact human life. And we're seeing that across the board. Robotic surgery is the single largest application of AI. Robotic surgery. I would hate to be or have any of my known friends on the table with the robot operating on it, but that's the reality. Robotic surgery is doing AI. If that model goes wrong, somebody's going to litigate. Compliance is going to be involved. So data protection is a critical gap in the third platform. You look at the third platform, people said, hey, we do a replica, that's the backup. Is that replica going to be around for 30 years? How do you maintain that replica for 30 years? And more importantly, how do you maintain compliance on that replica for 30 years? How do you make sure somebody cannot alter and manipulate data in a way that defeats the goals of SEC compliance? So those are the questions you got to look at when you start to transition away from big data as a science experiment to big data that controls human lives and shapes human lives. And that's where we are seeing the data pipeline. We bring the best of what we do. We bring performance. We bring the ability to span edge, core, and cloud. We bring SnapMirror and SnapVault, which is the smart data protection. We bring things like our backup partnerships with vendors where people want to work with a backup partner. And we look at industry alignments where we don't have a stake and we can partner across the industry. That's where we're looking at. So this is our architecture. And we don't just talk the talk, we deploy. This is an architecture we deploy in-house. If you've heard of ActiveIQ, which is our old ASUP system, ActiveIQ is a blueprint that deploys everything we've talked about. It's a 4 petabyte data lake, 300,000 endpoints that feed data into it. It leverages the edge, core, and cloud because you've got controllers feeding data in from the edge. Yes, we could do more at the edge. We are not yet there. Obviously, we are not the most demanding use case at the edge. This is telemetry data coming from controllers. It's not video data or image data coming from the edge. We do data archive in the cloud, but we give you the choice to also do cloud-based AI. So this architecture is resonating with our customers. The reason it resonates with our customers is when we are building and deploying ourselves, we are actually showcasing things that they couldn't even think possible. ONTAP can reduce this footprint down 10x. We have actually done that. A 13 petabyte data lake was able to shrink down to under 2 petabytes using storage efficiency from ONTAP. So that's the kind of thing that when you deploy HDFS on DAS, people don't even know possible. And the thing is, a data infrastructure team that is out in the app dev space doesn't even know what dedupe is. They don't even care what dedupe is. They don't think system. So bridging between the operations teams, the systems architects, and the app dev folks can produce powerful results for customers. So when you talk about stories that are 10x data reduction on multi-petabyte data lakes, you bet that resonates. That story resonates. The challenge we have is we have no competition. Nobody is talking the story that we're talking anymore. That is a challenge. You can have startups that will take a point piece and say, I'm going to do ultra-fast NVMe for a point use case. You're going to have the all-flash vendors saying, hey, I just built the fastest all-flash that will go after VMAX. Or you're going to have the flash NAS solutions that will go after the NAS vendors. But they don't span edge, core, and cloud. They don't have the cloud partnerships. And so our challenge is actually thought leadership. And that's where we believe systems thinkers, people like yourselves in the room, have a very powerful role to influence customers' thinking.
You don't think there are customers out there, the customers I talk to that do a lot of this are talking about it. They're just not talking about doing it with any of the big box vendors. They're doing it themselves. They're maintaining their own open source expertise. They're doing this. They don't need your help. They don't think they need your help. And it's hard to convince them that you need your help. They don't like paying for stuff. If they do, they'll support open source stuff. And these guys are pretty smart. In many cases, smarter than the integrators, sometimes smarter than the vendors.
Yes.
And they know their business use cases extremely well, sometimes better than you guys, from a general sense. And so, you're right, the other guys aren't doing it. But I would challenge the fact that you have no competitors. Your competitor is the customer.
I would say there
I
are.
agree with you. In fact, I would say that you're spot on. You're absolutely spot on. That is our biggest challenge. And you're absolutely right. The brain power of the big data staff at customers are people that work at Yahoo, at Uber, at Facebook. So these are very smart people. They are ultimately building technology that worked at Uber and Facebook because they could throw amazing amount of dollars at it as a startup or a web scale vendor with the cash reserves. And you can't do the same at Target and Macy's and Walmart and Whole Foods. So what resonates is TCO. And we have actually done TCO studies that are bringing this down to very quantific numbers. So we are able to show, we actually have a white paper out on this. We got a third-party analyst to assess. If you look at a Hadoop cluster, 100-node Hadoop cluster, the sizing of a Hadoop cluster is based on the data set per node as a function of the data-intensive operations of that server for the purpose of data management. If you took the data management out of the server, you've given it a lot of CPU cycles back. All of a sudden, that 100-node Hadoop cluster can shrink down to 50 nodes. So if you look at our white paper that breaks down the itemized view of TCO, we're able to shrink, and in fact, the paper says we are 50% cheaper than DAS by virtue of shrinking the server cluster. Now, guess what? None of the Hadoop vendors are going to tell that story because they license by server node of a Hadoop cluster. So you deploy Cloudera on a 100-node server cluster, they're making a lot more money on that 100-node cluster running DAS than they would if they were running a 40-node cluster running on ONTAP because their license cost just shrunk by 60%.
Yeah, but the customer can also just store their data lake in S3, pull it up into the Elastic, whatever Amazon's doing from a big data perspective. I can't remember the name anymore, but and spin it down. So you're comparing it to Hadoop when the target's moved elsewhere to much more what others might think to be not just cost effective but also non-disruptive from a data center. I don't need a data center for that. I don't need to have stuff to do that. I can do it fast. I can be flexible, and
absolutely agree with you. Right? Absolutely agree with you that customers want to use the cloud because they're done with operations. They're done with building data science skills that they can't hire and can't pay. Absolutely agree with you. But there are a different set of problems in the cloud that I haven't even touched on. The performance of S3 for these performance-hungry applications could use an alternative. When you look at NetApp cloud volumes, this is, I don't know if this is a secret or it's public news, but we deploy on dedicated hardware. NetApp cloud volumes is deploying on dedicated hardware. So it's an all-flash FAS serving NAS data directly. No surprise, we are outperforming EFS. So you look at cloud volume, I heard a stat, I don't know if this is true or not, but we were supposed to be 12 times faster than EFS. So when you put a performance-hungry application in the cloud, there's a use case around performance that people will look for a solution for. So yeah, it's different stories, but we think there's enough opportunity across the board. We're not going to be, I'm not claiming that we will be the one vendor that solves world hunger, but we see so many opportunities across the board to bring the value that systems thinkers have done for the last 30 years. Systems thinkers still have a role to play, in being able to decouple data from compute and let all of the web scale vendors add the value in the compute and still bring value to data. And we think that is dependent on people that can shape customers' viewpoints. So it's a point of view that is held by a minority, just like Brocade was a minority for Fibre Channel, but that didn't mean Fibre Channel died. As much as the Ethernet guys tried to kill Fibre Channel, it's still a thriving install-based protocol. And why is that? Because it solves problems pragmatically. It's a very pragmatic solution. And we think that there's a similar opportunity here, but it is subject to the ability to shape customers' thinking and shape the industry thinking.
For Santosh, for logistics, we probably need to wrap it.
Yes, so I'm happy to wrap on this. We can leave the slides in the deck, and plenty of opportunity to connect and talk about a lot of this offline.
You can take another 5 minutes if you want.
Okay.
It's up to you.
Yeah, so the couple of things I'll touch on are AI and what is changing from an AI perspective. Fascinating amount of change coming from AI, and we are in the midst of that because of two reasons. One is we believe that AI has changed the critical mass of vendors that customers want to talk to now. For 3 or 4 years, you recall I said earlier, the industry took a left turn. For 3 or 4 years, they were talking to Cloudera, Hortonworks, and MapR and thinking the systems vendors were dead. The return to GPU architectures has brought a focus back on systems and solutions around systems. When you're now building AI and deep learning clusters with hardware that is GPU-based, and you look at the set of startups that are building custom ASICs for AI, the hardware industry has now found a new cause to rally around. If you go back and research the number of hardware startups that are building AI custom chipsets, all of a sudden, hardware is back in vogue. When people said, oh, it's all commodity and nobody cares for hardware and kill all things hardware, AI has brought back the use of technologies like GPUs, custom ASICs, FPGAs, and a number of other offerings. So what AI has done for the industry, just like Brocade did for Fibre Channel, we've got a lot of gratitude to NVIDIA. We really do. I mean, I'm spending time weekly with NVIDIA. Luckily, they're down the street. So I drive down, we do lunch with them, they do lunch with us. We're partnering closely with NVIDIA. And we believe that NVIDIA is doing the entire enterprise industry a huge favor. They don't realize it because they've never been in the enterprise space. But we, seeing the connections, we can sort of connect the dots. And we think NVIDIA is doing what Brocade did for the Fibre Channel industry. By bringing back GPU architectures as a backbone of high-performance, data-hungry workloads, they're bringing back systems into where customers start throw commodity at it and goes away. So what has changed? There are a few radical things that have changed here. The first is this training cluster. AI is sort of a two-layered deployment. If you ignore the edge for now, at the core, whether the core or the cloud, AI has got a set of training clusters that may be 1 to as many as hundreds of GPU nodes that are fanned out for training. And then it's got a deployment model that's a model serving architecture. So there are vendors focused on the training side, there are vendors focused on the deployment side, and then there are vendors focused on both. And the needs of each are fairly unique. So you've got the training being a very bandwidth intensive workload where you've got streams of parallel workload, reads, almost 100% read workloads coming into the training cluster. And we estimate that a single NVIDIA DGX1 could be as much as 6 gigabytes of read bandwidth, thanks to Naresh's work that he's been doing. Naresh has been modeling out a lot of the AI. Naresh is sort of our data scientist before the term even existed, right? He's been the data scientist at NetApp before the term data science probably existed. And so he's been modeling a lot of what our AI bandwidth feeds need to be. And we think 6 gigabytes per second is sort of the state of the art of a DGX1.
We've seen that elsewhere.
Right. And so we're seeing the training cluster being a bandwidth workhorse. There are some verticals where it will be random reads as well. So depending on what kind of vertical use case you have and whether you're analyzing image data or sensor data, you've got large reads or small reads. We think that the deployment is going to be a DevOps focused. Think about GitHub. GitHub for code is going to evolve to GitHub for AI models. So we think that our role, and as you're probably aware, NetApp has a strong set of partnerships with the DevOps vendors and doing a lot in the DevOps space. And we see the GitHub and DevOps kind of model evolving for model serving. And a lot of opportunities there to position FlexClone and rapid set of model copies, and service levels for the models. Certain models are about to go into production. You want higher performance for that. Certain models are in test and dev. You can alter the QoS levels for that. So a lot of opportunity there. I think from a cloud perspective, there are several different ways you can use the cloud. You can use the cloud for GPU as a service. This is the shortest path to avoiding having to pay the enormous amount of money that NVIDIA is making off these GPU systems. A DGX1 server, I don't know if folks saw this, but a DGX1, we had to pay for this. This is how we felt the sticker shock. A DGX1 server is almost $200,000. You could take a Supermicro and throw in GPUs and probably build it at 30K or even 20K. Obviously, the crypto guys are doing it. There's no doubt that crypto mining is building this on laptops and everything else. But NVIDIA is making money selling the DGX1. The reason they're doing that is a hidden secret. They're providing the software support for the AI stacks. And nobody has. NVIDIA has become the Cloudera of AI. NVIDIA has become the Cloudera, Hortonworks, and MapR of AI. And we see a unique opportunity for us, NetApp, in that all of the other storage vendors have become part of server portfolios, and server vendors are building AI servers, whereas we are happy to partner with NVIDIA. So the reason that they humor and entertain us weekly in their building or they come over here is because we're talking about what can we do together in ways that we are happy to do, not being a server vendor. Not being a server vendor, I don't have to think about building my own server with GPUs as a product in my product line that competes with NVIDIA DGX1. I'm happy to take the DGX1 and promote it to our install base and promote it to the channel and the wars. So huge advantage of focusing on what you do well and not trying to play in a space where you're going to compete with other ecosystem vendors.
So you're not looking at adding AI capability into your on-premises core yourselves, like, for example, the ONTAP.
So we're already doing AI today. So we've got AI in our support systems. We partner with IBM Watson, and we have the, is it called Ilio? Ilio. So Ilio is our automated chatbot for support for NetApp based off IBM Watson. That is an AI-based support experience. We've got AI in ActiveIQ. So we're building AI into support functions. We're building AI into telemetry functions. We're starting to build AI into sizers that do sizing of the workloads. And it's going to expand. Obviously, we're going to look at AI everywhere. But at the same time, our customers need to look at AI, and we need to help them. And that's where we have a parallel role to play right now. So when you look at the cloud, there's an opportunity to do GPU as a service. Huge opportunity for NetApp there that I haven't even gone into. I could go a full hour on this. You can take production data that's wherever it is today. All of that Brocade-based Fiber Channel data, get a flex clone and snap error of that into the cloud, and now we are best friends with all the cloud vendors. I'm talking to IBM Watson. I'm talking to a bunch of other vendors where we don't need to do anything other than give them copies of production data in the cloud where customers can build AI in the cloud but keep production where it is. So GPU as a service as well as cloud AI makes us best friends with the cloud vendors because we're not competing on AI. We're happy to give the data to where they want to do AI. You can go up a level and say customers that are betting the farm on AI are going to build it on-prem, and they're going to do it for cost reasons and IP reasons and differentiation reasons. And for them, we will just do data tiering to the cloud, cold data tiering to the cloud.